Okay, everybody, welcome back. This is part two of the this is completing the square, but basically we're talking about general form and standard form for the equation of a circle. All right, so in the last video, I know it was a little long, but we basically covered a whole bunch of polynomial review in 13 minutes. So, and you could, kind of skip through some stuff like that. But I'm going to try to use these three examples to help you guys with the last parts of this chapter. Okay, so we have to do something called completing the square, and it involves the perfect square trinomials that I went over in the last video. So I'm just going to dive in. As a matter of fact, I took the same equation that the last video ended with. They gave us this equation. Now this is in what we call standard form. We can easily extract the center of the circle, which would be 2 comma negative 7, and we could find the radius by taking the square root of this number, which would be 3. But at the end of the video, the last video, I expanded this, all right, and then wrote it in general form. So what I want to do in this video is I want to show you how to go back and change general form back into standard form so that we can get the radius and the center, all right? So here's what we're going to do. In general form, everything's expanded and everything's kind of moved around and jumbled up a little bit, but basically they write it in the format x squared plus y squared plus or minus something x plus or minus something y, and then usually have an extra term here. So here we go. What I'm going to do is I've highlighted the x terms, so I'm going to write those together. I'm going to write x squared minus 4x, and then I'm going to leave some space here. You'll see why in a second. Now I'm going to go address the y squared, or the y terms, right? So I'll have y squared plus 14y, I'm going to leave a little space, equals negative 44, okay? So all I've done right now is just kind of reorganize, right? Put my x's together, put my y's together. Now what I'm going to do is this. I'm going to group, I'm going to put a little plus there, right, because that's positive. I'm going to group my x terms, leave a space, my y terms, leave a space, okay? As you can see, I'm trying to change it into this standard form. So now here is an important piece. We want to create a perfect square trinomial here. So what I want us to think about is in the last video, in order to find that last term, we took half of this and squared it, right? So what is half of negative 4? That's negative 2. Negative 2 squared will give me positive 4, okay? Now I'll come back to that in a minute. So all I'm doing is creating a perfect square trinomial. Actually, you know what? Now here, I'll stick with this piece here. So if you notice, I'll have x squared minus 4x plus 4. Now guys, in the last video, we talked about factoring this, but the factors are identical. So I know I'm going to have x minus something and x minus something. So what two numbers, when added together, give me negative 4, but when we multiply them, give me positive 4? Those are going to be negative 2's. Let me stick with this piece too. And remember now, guys, we can rewrite this as this binomial times the same thing. Oh, wait, I could rewrite that as a binomial squared. This term times itself. Now, if you notice, it directly or perfectly matches what we had in standard form. All right, let me keep going here. Now I'm going to go deal with my y terms. I want to once again create a perfect square trinomial here. I'm going to take half of the 14, which is 7, and square it. That's going to give me 49, okay? Now, I want to create the factors, the identical factors. So I need a number. When added to the same number gives me 14. When multiplied by the same number gives us 49. That's going to be 7, okay? So now I'll get my y plus 7, y plus 7. I can rewrite that as y plus 7 quantity squared. But I want you to notice something here, right? We should remember that the radius, or the radius squared, was 9, right? The radius was really 3. But I want you to notice what I have here, right? I have negative 44 on the other side. And obviously that doesn't match up. But I need you to look at this step right here, okay? This is where I want you to focus. Think about what we did here. In order to create the perfect square trinomial, I had to add 4 here. I also had to add 49 here. So in essence, basically, we made the left side of the equation 53 more than it was, right? We added 4, we added 49. That made this side heavier, if you think of this as a scale. So I've added 53 units to the left. In order to keep the equation balanced, I have to add 53 to the other side. That is probably the most common mistake made with completing the square. People forget that when you add things to one side, you have to also do it to the other to keep it balanced. So now negative 44 plus 53, what does that give me? That gives me 9. We're happy. From this equation, I can find my center. My center will be located at positive 2, negative 7, right? We take the opposite signs. And the radius is going to be the square root of 9, which is 3. Okay? So now that we've done one completing the square example, I want to go through the other ones. Guys, I've taken these questions directly from IXL. So I chose these because I thought these were a little tougher. This one's really tough, so we'll come back to that in a minute. But I want you to notice in this example here, our terms are on both sides. So what I'm going to do is I'm going to add y squared, because I want to get it over here with the x squared. Okay, I'm going to add 2x, I'm going to add 12y, and I'm going to leave that 10 there for right now. But here's why I'm doing that. I'm getting rid of those terms on the right, and now what I'm going to do is I'm going to add them to the left. I'm going to rewrite my equation. It's x squared plus y squared plus 2x plus 12y equals negative 10. I want to leave the number over here, okay? Now, if you notice, ladies and gentlemen, it looks like what I started with over here, okay? Now I'm going to go grab my x terms. I'm going to rewrite those. That's x squared plus 2x. I'm going to leave a space, all right, plus blank. All right, now I'm going to go get my y terms. So now I'm going to have y squared plus 12y plus blank. I'm going to leave my blank there. Now look, I think this might be a good idea. Just to remind myself, I know that I'm going to be adding things to the left side. Why not remind myself to add it to the right? Now, I'm going to group these. Put the plus there, right? I'm going to group these together and try to now create perfect square trinomials. Half of 2 is 1. 1 squared is 1. So right now I've increased the left side of the equation by 1. Half of 12 is 6. Squared is 36. Okay. So now what I'm going to do is I'm going to create, or excuse me, I've created my perfect square trinomial. So what I'm going to do is, and if you want, you can skip this step if you start to recognize it, but that will now factor into x plus 1 quantity squared. In the y examples here, right, I can't talk today. I've created a perfect square trinomial, and what that now allows me to do is to factor this with identical factors, okay? So I can now rewrite that as y plus 6 quantity squared. Now, remember, really important, we increased this side by 1 and 36. Together, that's 37. So I have to go to the other side here and increase the right side by 37 as well. So now, negative 10 plus 37 gives me 27. Now, let's be careful. The goal of the question was to find the coordinates for the center, which would be negative 1, comma, negative 6. Now, just because I'm thinking about it here, if they did ask me for the radius, let's be careful. This is not a perfect square, but so what? This is your r squared, right? So we're going to have to take the square root of 27. So the radius would be the square root of 27. But guys, in high school, we know that we always simplify our radicals. So I could break this up into radical 3, radical 9. So the radius would be exactly 3 radical 3. All right, a little tougher. All right, now brace yourself because this last one is a tough one. It's the toughest one I think I've seen so far on IXL. So I figured I'd put this on here to help you out. Now, immediately, I notice a 4 in front of the x squared, right? The y squared also has the same coefficient. So what I'm going to do is I'm just going to look across the board here and notice that everything is divisible by 4. So what I'm going to do is literally just divide everything by 4. All right? Everywhere. Okay? So here we go. I'm going to now have x squared plus y squared minus 10x minus y plus 15 equals 0. Okay? I'm going to send this number over here so it looks like the other two examples, and I'm going to reorganize. So I have my x squared and my minus 10x, x squared minus 10x, all right, equals, I'm going to subtract the 15 over. That'll be negative on the right-hand side. And now I'm going to grab my y's, y squared and minus y. Okay, I'm going to do the same thing we did above. I'm going to group. Okay, and now I'm going to create perfect square trinomials. Half of negative 10 is negative 5, excuse me, and that squared will give me 25. So let me see if we can, by now, skip to our perfect square trinomial in factored form, okay? So now, hopefully that makes sense. If not, you go back and you just add that extra step in here. Rewrite this as x minus 5 times x minus 5. Over here, now here's where it gets fun. Just like we did a few minutes ago, I took half of the middle term, which would be negative 5, and I squared it. So let's remember that the middle term right now is negative 1. Half of negative 1 is negative 1/2. Okay? So negative 1/2 squared is 1/4. Okay. So now this is tricky, okay? I'm actually going to show this step. So I know it's going to be y minus and y minus. So here, I'm going to go to the easy part here, right? These two numbers have to be the same, and they have to add to negative 1. So I'm thinking it's negative 1/2, or minus 1/2. And just to be sure, negative 1/2 times negative 1/2 gives me positive 1/4. So I'm done with the left-hand side, which gives us our center, right? I know they didn't ask for it, but the center would be located at, think about it, 5, 1/2, whoops, or 0.5, right? So that would be the center. But they did ask us for the radius. Now here's the tricky part, guys. Remember, I should be increasing this side by 25 1/4, right? Plus 25 plus 1/4. Okay, negative 15 plus 25 is 10. Plus 1/4 is 10 1/4. But if you notice on IXL, a lot of times they give you the fraction button to make. So, and I think so, but you check me on this, right? I'm pretty sure we have to write our answers as a fraction, but like I said, let me know, send me an email. But I gotta turn 10 1/4 into a fraction. So mixed number into an improper fraction. I'm gonna do 10 times 4, which is 40, plus 1, that's 41/4. Now, we're still not done with the fun. They want the radius of the circle. Remember that this is the radius squared. So in order to find the radius, we have to take the square root of that. So I want you to follow along here, right? So I have the square root of 41/4, but I'm gonna keep it going. Taking the square root of a fraction can be split up. You can take the square root of the numerator and denominator. Can I simplify or take the square root of radical 41? No, I cannot. It's already simplified, done. What is the square root of 4? That's 2, and that is our final answer, ladies and gentlemen. What is the radius of the circle? The radius is radical 41/2. I told you that was a tough one, so that's why I figured I'd include it. All right, so this should hopefully clarify any questions you have for the rest of the week. Good luck. I'll talk to you soon.